In this lesson, we'll discuss limiting reactant and theoretical yield. This is question number 1. The question reads, ammonia, which has the chemical formula NH3, can be synthesized by the following reaction, and that's shown below. Starting with 86.3 grams of NO, nitric oxide, and 25.6 grams of H2, hydrogen gas, find the theoretical yield of ammonia in grams. Let's start with a quick strategy as to what to do here. To determine which reactant makes the least amount of product, what we have to do is convert from grams of each reactant to moles. The reactant that makes the least amount of product is the limiting reactant. If you're confused by that, here's what I mean. The first thing that I'll do is write down the given numbers. We're told the mass of NO, which is 86.3, and it has 3 significant figures. And we're also told the mass of H2, which is shown right here. I'll write these masses and denote them as the letter M underneath each molecule. So M is equal to 86.3 grams and M for H2 is 25.6 grams. Using the mass and the molar mass, which I'll find next, I can find out the number of moles. So how do we find the molar mass? To do that, we'll need to use the molar masses of individual atoms found within each of these molecules. Starting with NO, we have 1 nitrogen, so we'll take the number 14.00 and add 16.00 to it. These two numbers combined is 30.00 grams per mole. And the molar mass of H2 is this number multiplied to 2. 1.008 times 2, and this number is equal to 2.016, and you can use your calculator to verify that. I'll write these numbers underneath as well. So here I have a molar mass, and I'll use the capital letter M for that, 30.00 grams per mole. The capital letter M here as well, 2.016 grams per mole. To find the number of moles for each of these, what I need to do is multiply the amount of grams with the reciprocal of these two fractions. Notice that this fraction and this fraction has grams over moles. Instead of grams over moles, I'll multiply it by 1 mole over the amount of grams. So starting with this number, we have 86.3 grams times 1 mole at the top, and at the bottom we'll have 30.00 grams. I'll use my calculator. 86.3 divided by 30 gives us 2.876. 2.876 moles. The same calculation can be done for H2. I'll take 25.6 grams and multiply that by 1 mole over 2.016 grams. Notice that the gram units will cancel out. I'll show that up here too. We have 25.6 divided by 2.016, and that gives us 12.69. 12.69 moles. Recall that at the beginning we had 3 significant figures. So keep that in mind for this number and this number. That red dot you see suggests that that's the last significant figure. Everything after that is insignificant. So we found the number of moles, and going back to our strategy, we said that we would determine the least amount of product by converting from grams of each reactant, which we just did, to moles of the reactant to moles of the product. So next what we will do is compare the number of moles of first NO, which has 2, to the number of moles of NH3, which also has 2. Because there is a 2 to 2 ratio, the number of moles of NH3 will be identical to 2.876. I mean, think about it. Let's pretend that you had a ratio, 2 to 2. And underneath this 2, I wrote down 2.876, and I wanted to find the equivalent moles of NH3. Cross-multiplying would give me the exact same number, 2.876. Let's do the same thing for H2 now. There are 5 moles of H2 to 2 moles of NH3. writing our number 12.69 underneath, and solving for x, we cross multiply. So we take the number 12.69, multiply it to 2, and then subsequently divide by 5. And that gives us 5.07. Of those two numbers, 5.07 and 2.876, which is smaller? The one that's smaller is 2.876. Therefore, we will use that as our limiting reactant. So what I'll do is write down for NH3, its number of moles is 2.876 moles. Let's go ahead and find its molar mass, because with the molar mass and the moles, we can find the mass. So the molar mass of NH3 can be found by taking 14.00 plus 3 times 1.008. 3 times 1.008 is 3.024. Adding 14 to that, and of course this can all be done on your calculator. I'm doing it manually. 17.024 grams per mole. I'll write this number right here. 17.024 grams per mole. And by multiplying the number of moles with the molar mass, I'll get the grams. So I'll take 2.876, multiply it to 17.024, and this gives me 48.96. Given that we need 3 significant figures, this 9 will go up to 0, and we're left with m is equal to 49.0 grams. Highlighting this number, 49.0 grams represents the theoretical yield of ammonia gas in grams. And there you have it. That is how to find the limiting reactant and theoretical yield. Make sure to watch question 2 for another challenging example.